All right, so we're going to talk about Comdb2, which is Bloomberg's highly available relational database system. It actually does use SQL and also uses SQLite as the front-end query processor and planner. And it's optimistic concurrency control and fully replicated and highly available. And it's also designed for very high performance, mostly focused on read performance. It has multiple isolation levels, including snapshot and serializable. Read-write transactions can run on any node. The actual writes end up being performed eventually on the master node. And there's a client library which provides transparent reconnection and resumption of queries should there be any issues like network issues or what have you. It has stored procedures via Lua, and then it's built on some other open source technologies like SQLite and VLDB and LZ4 and various other libraries that we use. And then here's a link to the VLDB paper from 2016, which discusses everything I just said in much more length than I can cover here. And this paper was written by the original architect of Comdb2, which is Alex Scotti. So, what about Tcl'? Well, I created Tcl' bindings for this because I like Tcl', and also given the fact that it already uses SQLite, it seemed logical that since we're running some of the SQLite tests which use Tcl', we should be able to run them more easily if we had native Tcl' bindings. So the bindings, they provide one command that's basically an ensemble, and then it has a bunch of subcommands. So then there's some instructions on how to get, if you want to play with it, you can visit this website or just visit the GitHub page and you can see how to install it and set it up. Here's just a quick overview of the bindings. I didn't want to go into too much detail because we don't have that much time, but it's very simple. So package require, open the database. The first argument is just the database name, which ends up being resolved using portmux, I believe, right? And then the last argument is what tier it is, and local means local machine. So if you're just testing, you're typically going to use local. And then once you have a database connection, you can just run queries against it. And it supports bound parameters and various data types that are all explained in the documentation. And then once you're done, you just use close. So here's an example of binding and then running a query with a bound parameter. And just normally I run unbind first because that way it avoids, hey, this is already bound error if you're reusing the same connection, because a particular database connection in their C API and also in the bindings can only have one statement going at a time. So it's not like sort of like the SQLite one where you can have multiple statements going. And so if you want to fetch results, it's similar to this. Once you do the run command, you can sort of iterate over your results and grab how many columns you have, what the names are, the values, the types, what have you. So we thought about TDBC for this, and the idea was that if we have this very low-level binding, we can kind of build all the TDB stuff on top of it because the bindings are a very thin wrapper over the C API, and so if we want to build more complex pieces, we can just use them to construct whatever is required for TDBC compliance. Okay, questions? Anyone?
Tell us a little bit about the application or what you're doing with it at Bloomberg that makes this useful.
So Bloomberg has a very interesting use case. They can't be unavailable. So we built this database with correctness and availability in mind. So a single Comdb2 instance is going to exist on anywhere between 8 and 16 machines. The data will be fully replicated on all of those machines. It's a single master system clients will connect into one of the replicants. It'll run SQL, and it'll get results, back from that. In the normal case, for read-only. If the machine should fail, then it just quietly connects to, by the way, depending on certain features that you have enabled, it can quietly connect to a different node and pick up in the middle of a transaction. And that's HASQL. Or if you would rather not, and get an error outright because your connection was lost, we can do that too. But, that being said, everything from schema changes to hardware failures was written with availability in mind. So we don't lock our customers out from the data at all. We can do completely one-line schema changes, and the old version of the table is seen until the very last switchover time. We can now in R7 we have the ability to do multiple schema changes at a time, provided that they are on two different tables. We can't do two schema changes on the same table at the same time, which is an interesting trick. We also have the ability to pause schema changes at the end. So if you wanted fine-grained control over when the new schema were to take place, you can issue a command and make it take place at that time. So it'll just sit there with the new table ready, and then you can say, okay, now this is when I want it to happen. So it's a very good system. It's used across Bloomberg for, I want to say, north of 85% of their data. The notable exception is tick data. So market data is generally not stored in Comdb2, but most of the other data is.
So there is this project called RQLite, which uses raft consensus algorithm. Are you familiar with that, and how does your solution compare?
I've seen that project. Our replication protocol is very similar to Raft.
We honestly, I read the Raft paper and we stole as much of it as we could. And so for our linearizable isolation level, we do almost exactly the same thing. So basically, we want to make sure that data is written is durable, and we want to make sure that you get the exact same results no matter what machine you're connected against. And we want to make sure that this giant distributed system behaves like the simplest single-threaded system in the world. And so we borrowed a lot of the ideas, behind Raft to get there. But before then, our election protocol for determining who should be the master was based on Paxos. It's a log shipping system that happens. In order to make election correct, we had to make some changes, and that we did within the past year and a half.
Anyone else?
So on GitHub, have you ever started doing any releases? So the lack of releases.
So, by the way, our idea with this is that we want to make sure that this software is stable enough to be moved into production at Bloomberg. And there was a lot of deviance between the pre-open source revision and the open source revision. There's a lot of changes, and so we're trying to be very, very careful. And our plan is that we're going to make it release after we have this moved to some production servers at Bloomberg. Right now, we're moving this to dev machines and moving it to alpha, and we're seeing what goes wrong. The other hurdle that we had whenever we created the open source version is we have to maintain backwards compatibility with every previous version of the software, and that ends up being kind of a hard problem. But we're at the cusp of getting this out there. I want to say in a matter of months we're going to have this on some production machines, and hopefully we'll go from there. The advantage of this, though, is that we're not going to market it as production until we've actually tried this in production. So I'm sorry. I mean, it's been a little bit slow, and honestly, I'm sorry about that. But the upside is it's going to be ready. It's going to be ready for use. It's going to be real production software that you should be able to put production data on.
Not really a question, but something that you mentioned to me earlier that I thought was really cool to pull up is this idea of queries that point in history.
Oh yeah,
which is a fairly unique.
Yeah. So we support snapshot isolation. We also support point-in-time snapshot isolation. And basically, what this means is you can say, begin snapshot transaction as of some point in time that passed. So there are some limitations. The point in time for this feature cannot cross the schema change. But otherwise, you can view the entire database as it existed at that point in time. You can see all the data that existed as it was then, which might be really, really useful for folks who want to need to audit their data at some given point in time.
Does that grow in size quite a bit?
It becomes harder and harder. So it becomes harder and harder the more writes there are, and so short. We try to put things in place to make it as easy as possible for us to go to. But of course, the more there is to unwind, then the slower these reads end up being. However, we have kind of an optimization where, imagine your cursor touches a page, and that page itself has not been changed. Then in fact, there's nothing to do. You can see all the records on that page. We can actually unwind the world at page level granularity. So,
but at some point you drop snapshots after there's no more clients that are going to be accessing.
So that's married intimately with log file, write-ahead log, right? So basically that defines how far back you can go, and that's like only as far back as your oldest write-ahead log. And so if there's an ongoing as of transaction, then we simply won't delete the log, right? And if you can't get back that far for an as of query, then we're just going to tell you, yeah, we can't do it.
The write-ahead log, how long you keeping is configurable, right?
Yeah, how long you keep the write-ahead log is configurable. So you can say, I want to keep, basically it's just, it's a log. It's a file sitting in the file system. So if you want to maintain 24 hours, then you just tell the system, I want to keep 24 hours of log. And, then it's just going to keep that many logs. It's only going to delete logs that are greater than 24 hours old.
Anybody else? That's all the questions. Okay, well, here's the links. It's on GitHub. Enjoy. Let us know if you run into anything interesting.
So we are somewhat ahead of schedule.